Chapter 7, Module 3. In this module, we shall discuss firstly universal covering space and secondly a general lifting theorem. In proving general lifting theorem, we utilize path lifting property of covering projection. So, we start with defining universal covering space and then we show that if it exists, then that must be unique. Suppose P1 and P2 are two covering maps. One is from x1 tilde and the other one is from x2 tilde. Now, a morphism of covering spaces over the base space x is a continuous function phi from x1 tilde to x2 tilde such that P2 composed phi is P1, that is the following diagram commutes. Now, if we take in particular the morphism phi as a homeomorphism, then we call that phi an equivalence of covering spaces. A covering projection Q is called a universal covering projection if for any covering projection P from x tilde to x, there exists a unique morphism phi from E to x tilde such that the diagram shown here commutes. That means, P composed phi is equal to Q. In such case, E is called the universal covering space of X. Now, this theorem says that if X has a universal covering space, then that must be unique up to equivalence of covering spaces. If possible, let us take two universal covering projections. One is P1 from E1 to x and the other one is P2 from E2 to x. Then, by definition of universal covering space, there exists a unique morphism phi from E1 to E2 such that P2 composed phi is P1. There exists a unique morphism psi from E2 to E1 such that P1 composed psi is P2. So, combining these two, we get P1 composed psi composed phi is P1 and P2 composed phi composed psi is P2. But the identity morphism IE1 is the unique morphism satisfying the condition P1 composed IE1 is equal to P1. So, psi composed phi must be IE1 and similarly we have phi composed psi is equal to IE2. Therefore, E1 and E2 are same up to equivalence of morphisms. So, we have proved that if a universal covering space exists for a topological space, then that must be unique. But that theorem does not guarantee the existence of universal covering space for any topological space. Now, we shall prove one result which is called general lifting theorem, which sets a necessary sufficient condition for a continuous function from a path connected, locally path connected space to possess a lift. We state a lifting theorem. Suppose P is a covering projection which takes x0 tilde to the point x0 in the base space. Y is a connected and locally path connected space and y0 is a point in capital Y. F is a function from y to x which sends y0 to x0. It is a continuous function. Then that continuous function f has a lift f tilde from y to x tilde which sends y0 to x0 tilde if and only if the corresponding induced homomorphism f sharp takes the fundamental group pi 1 of y based at y0 inside p sharp pi 1 of x tilde based at x0. So, we start with the fact that suppose f tilde exists, then by the commutativity of the diagram as shown here and applying the functorial property of fundamental groups, we get that p composed f tilde sharp is equal to f sharp. But now p composed f tilde sharp as it is equal to p sharp composed f tilde sharp, we can say that image of f sharp is contained in image of p sharp. That is, f sharp pi 1 y y0 is contained in p sharp pi 1 x tilde x0 tilde. Conversely, suppose the condition is true. We choose any point y from capital Y and choose a path alpha from y0 to y. Then alpha is a function from I to y and f is a function from y to x such that alpha sends 0 to y0 and f sends y0 to x0. Therefore, f composed alpha is a path from x0 which is fy0 to fy. By path lifting property of the covering projection P, there exists a unique path f composed alpha whole tilde such that f composed alpha whole tilde evaluated at the point 0 is x0 tilde. Now, we define f tilde at the point y by the terminal point of that path f composed alpha tilde. We claim that such f tilde is well defined. Now, how do we prove that f tilde is well defined? Let us take beta, a path from y0 to y, then the product of paths alpha star beta inverse will represent an element of pi 1 y y0. So, f sharp of the class alpha star beta inverse is a point in p sharp of pi 1 x tilde x0 tilde. Therefore, there exists class W in pi 1 x tilde x0 tilde such that the class P composed W is equal to the class F composed alpha star beta inverse. Now, since P composed W is path homotopic to F composed alpha star beta inverse, lifting these paths to capital X tilde beginning at x0 tilde give paths with the same endpoint. Also, W lifts P composed W and it ends at x0 tilde So, a lift sigma of F composed alpha star beta inverse that begins at x0 tilde must also end at x0 tilde. Suppose we take x1 tilde as the point sigma of half. Then sigma restricted to 0 half closed interval lifts alpha beginning at x0 tilde and ending at x1 tilde. Similarly, sigma restricted to the closed interval half 1 lifts beta inverse beginning at x1 tilde and ending at x0 tilde. So, the curve lifting F composed beta starts from x0 tilde and ends at x1 tilde. Therefore, F composed beta tilde evaluated at the point 1 is equal to x1 tilde, which is again equal to F composed alpha tilde evaluated at 1. We now show that this F tilde is the desired lift. The way we have defined F tilde, it is evident that it satisfies the property that P composed F tilde is equal to F. So, for F tilde to be a lift of F, we need to show that it is continuous. Let V be an open set in X tilde. We have to show that F tilde inverse of V is open in Y. For any Z taken from X tilde, there exists an admissible open set UPZ containing the point UPZ in X. By definition of admissibility, P inverse UPZ is expressible as disjoint union of some open sets W betas. So, capital V is equal to disjoint union of V intersection W beta, where the disjoint union is taken over the set V, and hence F inverse V is equal to disjoint union of F tilde inverse of V intersection W beta, where the disjoint union is taken over the points in V. We shall show that each F tilde inverse of V intersection W beta is open in Y. Since P restricted to W beta is a homeomorphism, P restricted to W beta will take V intersection W beta to an open set in X such that P restricted to W beta on V intersection W beta is contained in UPZ. F being continuous, F inverse of that set is open in Y. Moreover, subset of an admissible open set is admissible. So, P restricted to W beta operated on V intersection W beta is an admissible open set in X. Consider the set A as F inverse P restricted to W beta of V intersection W beta, and suppose A is equal to union of AI, where each AI is a path component of A. Since Y is locally path connected and A is open in Y, it follows that each AI is open in Y. If we can show that F tilde inverse of V intersection W beta is a union of some path components of A, then the proof is complete. So, we establish that in two steps. In the first step, we show that if gamma is a path from y to z in capital Y such that the entire path f composed gamma is contained in some admissible open set U in X, then f tilde y and f tilde z lie in the same sheet in P inverse U. Suppose gamma is a path such that it starts at y and ends at z. So, f composed gamma is a path from Fy to Fz. By path lifting property of P, there exists a path f composed gamma tilde such that f composed gamma tilde on 0 is f tilde of y. Now, alpha being a path from y0 to y, alpha star gamma is a path from y0 to z. That is, alpha star gamma evaluated at 1 is z. As f composed alpha star gamma has a unique lift, f composed alpha star gamma tilde, which can be expressed as f composed alpha star f composed gamma tilde and which begins at x0 tilde, we have f tilde z as f composed alpha star f composed gamma whole tilde evaluated at 1 is equal to f composed alpha tilde star f composed gamma tilde evaluated at 1. In other words, f tilde z is the end point of f composed alpha tilde star f composed gamma tilde and therefore of f composed gamma tilde. If V alpha is a sheet of P inverse U containing f tilde y, then P restricted to V alpha being a homeomorphism, V alpha contains the entire path f composed gamma tilde and hence its endpoint f tilde z lies in V alpha, which completes the proof of step 1. Now, step 2. For each I, we shall show that either f tilde inverse V intersection W beta does not intersect with AI or AI is totally contained in f tilde inverse V intersection W beta. For if y is taken from this intersection, we shall show that AI will be totally within that set. Let us take z from AI. Since y and z both are in AI and AI is path connected, there exists a path gamma starting at y and ending at z. Also, P of V intersection W beta is evenly covered containing the path f composed gamma. Now, using step 1, f tilde y and f tilde z lie in the same sheet of P inverse of P V intersection W beta. That means the set V intersection W beta. Hence, Z is a point in f tilde inverse of V intersection W beta as desired. So, we have proved that f tilde is a lift of f. Now, a very important corollary follows from that theorem. that a simply connected, locally path connected covering space is always a universal covering space. How do you prove it? We take P tilde, a covering map from x tilde to x, taking the point x0 tilde to x0, and since x tilde is simply connected, pi 1 x tilde is 0, I mean trivial. If P is any covering map from a space E to capital X, which takes the point E0 of capital E to x0, then the condition of the theorem holds trivially. Now, by lifting theorem, there exists a lift f from x tilde to E such that the following diagram commutes. That means P composed f is P tilde, and so x tilde x0 tilde becomes the universal covering space of the given space X. So, in the last corollary, we have seen how powerful the theorem is. With this, we conclude chapter 7, module 3.